Okay, here we go. Dear experts, scholars, and students, good evening, everyone. My name is Zhiqiang. I come from College of Mining Engineering of Taiyuan University of Technology. The title of my report is Experimental Study on Flowing Sand of Quartz Sand with Different Particle Gradation. Next, I will report on the following 4 aspects. First, research background. For the war, as a kind of disaster with a wide range of influences, destructive and deep consequences, flowing sand often causes effects on foundation, buildings, structures, and other projects, and brings huge property losses to human society. The main factors of flowing sand include water, ground vibration, infiltration characteristics, material components, and other factors. Scholars have fully explored the association between each factor and flowing sand, but have not revealed the process of stay sleep before and after the time of flowing sand, not explore the influences of carbon condition between different groundwater level rise rates and material components. Based on the flowing sand theory to carry out dynamic water test, pure quartz is taken as the main research objects, and the influences of different dynamic water race condition is considered to capture the moments of flowing sand occurrence under 2 coupling conditions. 2. Experimental program. According to the medium particle size, the required specimens were made with the artificial mixing ratio of the mass percentages of each particle size, and a total of 5 different particle size graded croissant was prepared. The particle gradation curves of each specimen were shown below, and the median particle size of each specimen include 2.01, 1.59, 1.50, 0.71, and 0.43 millimeter. A self-developed dynamic water penetration test devices was used to conduct the test. A glass rotor flow meter was installed at the water injection port, allowing real-time monitoring of the water injection rates. Micro pressure sensor were used to monitor the pressure values at different height positions of the quartz sand specimen. Adopt the control variable method to gradually carry out the dynamic water permeation test under the condition of each factor variable. Each group of quartz sand specimen undergo 5 dynamic water permeation stages. Each stage permeation time lasts 10 minutes. 3. Experimental results. The water flow from the top of the permeator needs to be collected and stored during the test, and the percolation volume is collected separately during each permeation stage. As a result, the research between different medium particle size and percolation volume was plotted. The percolation volume of the quartz sand was not affected by the medium particle size, indicating that the medium particle size index had little effects on the pore ratio of 5 groups of quartz sand specimen. When the moving water rate is between 50 to 150 milliliter per minute, the actual seepage volume is slightly lower than the theoretic seepage volume, and in individual seepage stages, the actual seepage volume is slightly higher than the theoretic seepage volume, which is mainly due to the test errors in the connection of seepage collection and seepage volume collection in each stage. Then, when the moving water rates reach 200 milliliter per minute, the actual percolation volume is higher than the theoretic percolation volume, which is due to the capillary symphony effects, which speeds up the water flow and causes the percolation volume to be larger. The relationship between different dynamic water rates and seepage volume was plotted. The quartz sand specimen showed a positive correlation between the percolation volume and the different dynamic water rates, and the There was a linear relationship model. Therefore, the sandy soil of civil engineering foundation carried out by human society will not have significant impacts on their infiltration characteristic when the medium particle size is used as an indicator to carry out sandy soil feeding. The pressure value monitored by the microsensor at different height position were plotted against the rate of moving water. At top layer, turbulence variation of quartz specimen pressure values at top layer height position with increasing saturation time. When the medium particle size was 1.9, with the increasing rates of moving water, the special reconstruction of quartz particles occur, and the phenomenon occur at the moment of 3,000 seconds, but only lasted for about 1,000 seconds. Then, the 3-point samples have faster reconstruction phenomena under the condition of small dynamic water rates. The 4-point specimen had the first flowing sand phenomena after reconstruction. Therefore, then, when the medium particle size is 0.43 mm, the quartz sand specimen cannot even for a less stable and solid particles population space, and the complete flowing sand phenomenon will occur much earlier. Therefore, the particle gradation determines the possibility of flowing sand phenomena, and the medium particle size boundary when flowing sand occurs is 0.71 mm, while the dynamic water rates determines the moments when flowing sand phenomena. At the height position of metallurgy was further investigated. When the medium particle size was 2.01 and 1.59 and 1.15, the reconstruction phenomenon did not occur. When the medium particle size was 0.71 and 0.43, the reconstruction phenomenon occurred for a short time, but the specimen soon entered the particle space reconstruction again. At the highest position of bottom layer was investigated. There is no reconstruction of flowing sand phenomena. According to the installation height of microsensors at different height position, it is inferred that the thickness of the quartz sand specimen flowing sand in this test is around 16 mm at top layer. For flowing sand mechanism, in the process of flowing sand geological disaster mainly goes through 3 stages. First, in the natural environment, the solid particle of sand soil are mainly quartz sand and contain some clay and fine grace. The special structure is tightly grouped together by geological deposition and human engineering activities, forming a stable and solid particle space, which is called flow period. Second, when the water table rises, water will seep along the pores between the particles. The amount of water seepage is controlled by the porosity and dynamic water pressure. Due to the infiltration of water, the special structure in this is reorganized, breaking the original stable and solid seepage space, which is called reconstruction period. Third, when sandy soil is subjected to ground shaking and other effects, the pore water pressure will increase sharply, the original stable space will be damaged again, and the solid particles will return to the reconstruction period again. The flow period and the reconstruction period are continuous circle. Sandy soil will only occur under the condition that the established particle gradation and dynamic water pressure are satisfied at the same time. Then the solid particles will enter the circle state and will enter the suspension state completely, which is called flowing sand period. Thank you to all the experts, scholars, and students for listening. Thanks.